So here we are discussing two dashboards in the IT operations context. The first dashboard is incident analyst, is for the incident analyst. It's for incident management, and the scope here is one application and application performance and availability related incidents. The Prima application response time is shown on the first visual. It's measured in milliseconds in the y-axis and time on the x-axis. It is interactive, where you can change the time window, make it a 30-minute time window, make it a 15-minute time window, as you please. Obviously, this visual can be extended beyond the 1 hour time window, so you can have dashboards, similar dashboards for 2 hours, 4 hours, 24 hours, as the need be. Now, the thresholds here are set at 3K, around 3K to 4K for that being the expected response time for this application. Anything beyond that is going into the amber and red area, and anything beyond 5K is your breaching SLAs. Now, once you have an application and response time issues associated with the application, the incident analyst, the first question the incident analyst would like to know is, what are the components that enable that application and where are they located? And that's this diagram, this visual on the second row, which is the data center layout for the application. There are four columns. Column A is rack A, column B is rack B, column C is rack C, and column D is rack D. And the color codes are saying that this components is either offline for maintenance or offline for repair mode or online and available. And then the right here is the different components and their response time. The cumulative response time of all these different components gives you the overall application response time, right? So if the application response time was around 7,000 milliseconds, or in this case about 16,500 milliseconds, that is the cumulative of all other components that enable that application functionality, plus some of those unknown latency that's in the network which cannot be assigned to a certain component, right? So that is a cumulative figure. So that helps you to understand what component here could be the culprit or could be associated with this abnormal application response time. Visually seeing that, we can see that the database component is probably the one which is closest to the application response time. So there's something happening with the database that might be impacting the application response time. So that this visual helps you to not only to help you with the diagnosis. So the first visual is going to help you with detecting incidents and logging them and classifying them. The second visual is going to help you understand this. The second and third visual are going to help you understand what's happening with the components that are enabling that application, which in turn will help you diagnosis with incident diagnosis. The third row and the fourth row are nothing but event trees. So during the same time window, between 9 a.m. and 10:01 a.m., there are hundreds of events that are occurring in the data center. These events are captured and correlated based on a set of criteria, including time order of occurrence, using certain set of algorithms, and captured as event trees. And event trees that are related to this application and this application response time are presented in this first visual. The top two event trees, the ones which have the highest probability scores, are presented here. Each circle here represents an event. The bigger the circle, the higher the event tree, the event severity. The color code is actually associated with the component domain. So if it's blue when it's an app server, and when it's a specific app server, so each component or configuration item has its own color code for that particular event tree. Not only that, now once you know that this event is associated with this configuration item or component, you can also physically see that that component and in the data center layout, as well as know who is responsible for administering the component, Peter Bass, and who could be helping us, who could be in turn helping us with the incident diagnosis for this incident. When we go to the second dashboard, this dashboard is actually meant for the problem analyst. He's looking at a similar visual, but his first task here is, after logging this as a problem, to identify potential root causes. So in his case, the top 4 event trees are popping up in his dashboard. So the criteria here is the top 4 based on probability scores with regard to how closely these event trees are associated with this application response time functionality. So the dependent variable here is the application response time. And he's looking at a similar thing, and he makes decisions about, should there be a root cause associated with this CI, root cause analysis initiated associated with this CI and this event tree. And to make those decisions, he has data now which captures things like time order of occurrence of the events, what was the event about, who is the RCA analyst, and in turn, this is he has access to the incident dashboard also, and combining the two, this is going to help him make decisions about the number of RCAs that are needed, as well as which CI should the RCAs be conducted for, and therefore which RCA analyst. So the RCA analyst is also identified by CI. Which RCA analyst should also be assigned to the RCA project to do the root cause. So he might decide that out of those 4 event trees, only 2 of them warrant an RCA, and kick off 2 RCA tickets as part of the problem ticket and assign them to the relevant RCA owner. Typically, the RCA owner will be associated with those CIs that are part of the root event or the first event that occurs in the event tree. And in very rare cases, it is not the first event. But this dashboard is meant to help the problem analyst identify potential root causes associated with the problem here, which is the application response time problem, and each of these event trees associated with potential root causes. And they start off with things like database locks, web server application, number of end users threshold being breached, temperature being breached for one web server, and temperature being breached for another web server. Any of these could be potential causes, but additional logic and additional data can help them determine what was the root cause, and that's where the RCA analysis work starts. So I'm going to stop here. Thank you.